noble gas configuration is another way of writing an electron configuration or an orbital map. So basically, it is a shortcut for writing electron configurations. You're basically using the noble gas in the period above to represent all full orbitals before the period in which the element is, so that you don't have to write like 1s2, 2s2, 2p6. If it's in the third row, you could just be like, it's all full up to neon, and then write the third row, which is a nice shortcut. So let's talk how to complete a noble gas configuration. We're going to be using your periodic table or your electron configuration periodic table, and what you have to know are the shortcuts for your noble gases. Now they're written over here, but I know my handwriting sometimes is a little tricky. So for your row 1 noble gas, which is helium, the shortcut for it is helium in brackets. For your row 2 noble gas, which is neon, you're writing neon in brackets. For your row 3 noble gas, you're going to write argon in brackets. For your row 4 noble gas, you're going to write krypton in brackets like this. And it does have to be the chemical symbol, not the full name. For your row 5 noble gas, is going to be xenon in brackets, XE like this. And for your row 6 noble gas, it's going to be radon in brackets. And that is like that. So let's talk about the steps to using the electron configuration periodic table and our noble gas shortcuts to write a noble gas configuration. So the first steps are the same as either orbital maps or electron configurations. You're going to find the element on the periodic table and you're going to put your finger on it. Then you're going to figure out what row it's in and write the noble gas for the row or period above it. And then just list all your full orbitals after the noble gas, and then write the electron configuration for the element that your finger is on. So let's walk through this. We're going to do the electron configuration of aluminum. Aluminum's in the third row. So we're going to write the noble gas in the row above. That's neon. So we're going to recognize that neon's in the noble gas in the row above, and we're going to write neon in brackets. That's brackets, big N, little e, and brackets. Then we're going to write all full orbitals before our finger after neon. So we're going to start at the end of row 3, and our first full orbital is 3s2. We're going to write 3s2. We do not have another full orbital, so we go ahead and write what's under our finger. It's the p block, which we know it's the row number, so we know it's got to be 3. It's the p block, so we know it's p, and it's in that first column, so it's 3p1. And our noble gas configuration is neon 3s2 3p1. Okay, let's do the noble gas configuration of iron. When you find iron, it is in the 4th row. There it is. So you're going to find the noble gas in the 3rd row. So looking on the 3rd row, our noble gas is argon, right here. So we're going to go ahead and write argon in those noble gas brackets. So it's brackets with an AR in it. Then we're going to go along the 4th row and fill in all the full orbitals on the 4th row before our element. So we're moving along the 4th row, and our first full orbital is 4s2. We don't have another full orbital, so we go ahead and recognize that iron's in the D block, so its quantum number is rho -1, so D starts at 3, so it's going to be 3D, these are in the D block, and then we are 6 columns over, so it's going to be 3D6. 3D6, that is our electron configuration for noble gas. Argon 4s2 3d6. Okay, so let's do the same thing for iodine. Iodine is in the 5th row P block. So we look at the 4th row noble gas as our starting point, and that is xenon. So we start with, sorry, that's not xenon. That's krypton. I can't even read my own handwriting. I apologize. That is krypton. So we start with krypton in brackets, Kr. Then we go along the 5th row and we write in our full orbital. So our first full orbital is 5s2. We write that right after krypton. We keep moving along and our next full orbital is 4d10. We write that again after krypton. We keep moving forward, we don't have another full orbital. So we can go ahead and deduce that because we're in the p block and in the 5th row, our quantum number is 5. So it goes 5p and we're 5 columns over, so it's 5p5. So here's the thing with both electron configurations and noble gas configurations. You can write them in the fill order, the way we're doing, or you can write them in quantum number order, which is fine, which would put the 4D before the 5s. Both are acceptable ways of writing them. Final walkthrough is the noble gas configuration of thallium. Thallium's in the 6th row, so we use the noble gas from the 5th row, which actually is xenon this time. So we start with Xe in brackets. We go along the 6th row in order to fill in those full orbitals. So our first full orbital in the 6th row is 6s2. Remember, going along after lanthanum, we have to jump down to the F block. So our next full orbital is 4f14. We've moved back up to the D block because we're in the P block, so we've got to fill in the D block before, which is 5d10. We have no more full orbitals before thallium, so we go ahead and can deduce that thallium's in the P block in the 6th row. 6, that is also the quantum number of the P block, so it's 6p. It's in that first column, so it's 6p1. Okay, time for some independent practice. Please go ahead and write the noble gas configuration for magnesium, arsenic, zirconium, and radium. So let's go over the answers for these noble gas configurations. Magnesium's in the 3rd row, so you'd use the noble gas in the 2nd row, which is neon, so it's neon, then 3s2. Arsenic's in the 4th row, so you use the noble gas from the 3rd row, so it's Ar, 4s2, 3d10, 4p3. Zirconium's in the 4th row, so zirconium's in the 5th row, so you use the noble gas from the 4th row, which is krypton, so it's krypton, 5s2, 4d10. Radium is in the 7th row, so you use the 6th row noble gas, so it's radon, 7s2.